Guys, just I'm telling, just like yesterday, I have taken a lot of time on motivation part. Now it is not like that, guys. Compulsory, go through all personal questions, everyday practice those things, and as well as the newly available things, currently trending technical issues also. Please go through it. Okay. We discuss what are the system configuration and how to check system configuration, how to tell answer for how to check system, and also what is network, interconnection of two or more devices, what is networking, communication between two or more devices. Internetwork is a connection of two or more networks. Internetworking means it is a communication between different networks. So when you are connecting a devices, okay, so different ways to we can able to connect. So based on that, we can tell different topologies are came into work. So bus topology, ring topology, mesh topology, star topology, hybrid topology, tree topology, point-to-point topology, point-to-multi-point topology, like the different type of topologies are there. Okay, bus topology, the devices are connecting to directly on a backbone wire of to a backbone wire. In a ring topology, one device is connected to other device is connected to another device is connected to another device. Finally, last device is connected to first device. Mesh topology, every device is connected to all other devices. Okay. Star topology, there is a centralized device, either it is hub or a switch. The devices are connected to hub or a switch. We can scale the star topology, okay, by connecting to from one hub to another hub or one switch to another switch, like that, and we can connect a multiple devices in a single segment or a single LAN connectivity. Point to point means two devices are connecting directly, either D to hub point to point, E to hub point to point only. Okay, router to router, PC to PC, so point to point, router to router, point to point. But one router is giving connected to multiple things. This is like a main office. These are branch offices. Tree topology, there is a one backbone wire and the backbone cable with different devices are connecting to this backbone cable only. Okay. So different topologies like other some star topology or some other ring topology or some server directly connected to this backbone wire. Okay. So different type of networks we discussed: LAN, CAN, MAN, WAN. So local area network, campus area network, metropolitan area network, wide area network. So LAN is a local area network. It's a pure private network. It is. Campus area network, which is a combination of multiple LANs, but within the campus only. So not outside communication, not a global communication. MAN, so metropolitan area network, within the city, the devices can able to communicate. Within the city, they are communicating. WAN is a wide area network. It is a global network. Some different locations, different organizations. For example, 70s in Hyderabad, 70s in Noida, 70s in Pune, 70s in Exton, 70s in New Jersey, 70s in some London, New York kind of stuff. Okay, so these organizations are able to communicate each other through the WAN connectivity, intranet and internet. Intranet is a local, like a LAN. Within the LAN, you are communicating each other. It is a intranet. For example, your server is in your network, in your local network. That is a intranet. You are communicating to your server in your local network. That is intranet. For example, your destination, your server is outside of your local network. So you have to communicate through internet only. So for example, there is a google.com. So you want to communicate to google.com or facebook.com, youtube.com. These are all outside of your local network. So what to do? You have to communicate through internet. To get internet, we need ISP, Internet Service Provider. To connect ISP, we need a modem. So modem is used to connect to ISP. So then we will get a internet. But internet is outside connection, different network, logical network it is. But in our local network, we are using different logical network, different private network it is. Okay, in LAN, we have a devices with some private IP addresses, private network, different logical network. And outside, there is a different logical network, public network it is. How to communicate between these two things? We need a router. Router is a internetworking device. It makes communication between different networks. Okay. Next one is here I use a switch or a hub to connect a wide kind of devices. To connect a wireless devices, I use a wireless access point kind of devices. Okay. Nowadays, we are having in our home Wi-Fi routers. These Wi-Fi router, one side WAN connectivity that is connected to ISP, and that part we can see it is a modem, and also it is connecting our devices, our mobile phone, laptops, desktops, TVs. We are getting connected in our home devices or office devices. So how it will make communicate between our devices to outside network through router. Wireless access point, because we are connecting wirelessly also, with wire also we can able to connect it. So one Wi-Fi router is a combination of multiple devices. Depends upon Wi-Fi router, guys. Not always. It's not a general, not a generic point. It is not always same, but sometimes most of the we are using nowadays the Wi-Fi router. It's combination of modem, router, wireless access point, and hubbers, such kind of stuff. Default gateway. What is a default gateway? So when you want to communicate outside of your network, so then you have to go through the default gateway address only. Okay. So in this case, it is our Wi-Fi router is act like a default gateway. DHCP server. So when you connect it to your network, automatically you will get an IP address. Your system will get a IP address. You have a mobile phone. When you connect it to internet, when you connect it to network, so automatically you will get an IP address. From where you will get an IP address? System don't generate, right? System generated, that is different one. Okay, you are getting an IP address from DHCP server. It is a server. So in general, we know we don't have any DHCP server in our network. So of course, our Wi-Fi router act like a DHCP server. In our organization, they use a Windows servers or Linux server for a DHCP purpose. DNS server, local DNS server, not exactly, it is not a internet DNS server. The internet DNS servers are different. Local DNS server means you open a website, for example, www.youtube.com, www.google.com, facebook.com, or studio.youtube.com. Okay. So you are typing a name, but with the name we can't communicate. We have to communicate with the IP address only. So you know the name, but you don't know the IP address. To whom you have to ask? You will ask your local DNS server. The local DNS server do certain queries and returns an IP address to you. It will give you an IP address of youtube.com, IP address of facebook.com, IP address of google.com. We should not say that kind of stuff. We have to tell complete thing like docs.google.com, meet.google.com, mail.google.com, www.facebook.com, www.youtube.com, studio.youtube.com. What is that? That is a remote server name, FQDN. Okay, you know the name, but you should have a you should have an IP address to communicate. Who is giving an IP address to you? This one. Simple to understand. DHCP assign an IP address. DNS give you an IP address. Small difference is there. Okay, in wording. Functionality is different. Already said what is the default gateway. And we discussed about hub, switches, routers, modems. This part we discussed hub, repeater, switch. Okay, modem, router. Now we will go into it. Okay. So hub is a device which we connect in a LAN purpose. Star topology it is a hub and switches star topologies only here. Okay. LAN and we use in a LAN communication small networks. Hub is a non-intelligent device. It does not understand MAC address and IP address. It is used in a LAN communication, suitable for a small networks. Why? Because it do broadcast packets to every device in the network. So if you do like that, so more number of collisions occurs at hub. So packet data loss is there. If you connect a large number of devices, okay, so you want to use large network, big network, large number of devices are there. So more collisions, more that packet data loss occurs. Okay. So point is it's a layer 1 device as per OS layer and hub broadcast packets to every device in the network. So whenever you want to send a packet from A to B, but the same packet is also go for a C, D, E, F like that. Okay. Repeater is repeat the signal. So sometimes the signal cannot go with longer distances, not more than 100 meters. Signal become weaker almost at 100 meters of your regular LAN cable. So what we do, we use a repeater repeat the signal, so then we can communicate long distances. Another repeater, best example nowadays for a repeater is Wi-Fi extender, because when you are having a distance from your Wi-Fi router, so you can't get a proper signal. So what to do? Use Wi-Fi extender. Again, switches guys, hub and switches, there is a difference. Hub and switches, okay, switch is an intelligent device, switch understand MAC address, not IP address. Switch you maintain a MAC address table and it is used in LAN communication like a hub, okay, and it used in a small and large networks. It is a layer 1, layer 2 device as per OS layer. Large number of devices can connect. Large number of devices. Switch initially broadcast to every device in the network like a hub. Switch LAN MAC address of a devices connected to switch port. Maps that MAC address to switch port number. Map called. Okay, so what I am doing. So like a hub, switch also broadcast the package to every device in the network. But so while while devices are communicating, the switch will get the MAC address of the devices and the port number of the switch. They'll map it. So this is called a MAC address table. MAC address. Okay. So whenever a device is send a packet to another device, switch verify the destination device MAC address and which port in the MAC address table it forward the packet. Okay. So using a MAC address table, it is very easy to do communication in a unicast way because of this. Yeah, tell me.
Sir, MAC address table we will create or it will be given to us?
No, it won't give you anything.
Oh.
Switch inside, there is a mechanism. So like which device is connected. So whenever the device is sending a message to someone, packet is traveling, right?
Yeah, yeah.
The packet contains the source MAC address. For example, APC is there. APC MAC address. Okay, APC IP address will go. Destination is BPC. BPC MAC address. BPC IP address. This is a destination. This is the source. A send a packet to B. But packet, when it is passes through this switch, the port number is 1. A's MAC address, right? Source MAC address. It will table A's MAC address, port number 1. Like when devices are communicating each other, it learns exactly say it learning the MAC address based on the source only, not based on destination. Okay, so it will map for mapping purpose. Okay, so whenever a device is sending a packet, like a C want to send a packet to A. So again, what is destination MAC address here? A's MAC address.
Yes.
Okay, source MAC address is C's MAC address. For example, C is connected at 3. So C's MAC address 3. Now, what is the destination? A's MAC address. Where is A's MAC address? At port number 1. So then it can able to send directly. It no need to wait for a complete MAC address table creation. So first it will check MAC address table. Destination MAC address is there. Which port number it will forward. If it is not there, it broadcasts table 1.
Okay, sir.
Okay. So good. Of course, for every 3 minutes, it will be flush entire data. Again, it will recreate. If there are so many reasons, this is enough for you. Okay. So switches initially broadcast packets to the every device in the network, like a hub. Once it is learned MAC address of devices and created a MAC address table. Using this MAC address table, switch unicast the packets to destination device. Okay. Switch is a single broadcast domain and multi-collision domain. Because of this unicasting, it reduces number of collision, less packet data loss. Collisions may occur at port level, not entire switch. Okay. Of course, two functionalities. One is MAC address learning and forwarding. And there is some point I written working with floating and unicast. This part is unicast. MAC address table part is unicast. Floating is there, that is one mechanism that's not required. So different type of switches, cut through switches, store and forward switches. In switches, switch is a L2 device, hub is a L1 device. Hub used in small networks, switch used in small and large networks, both using LAN communications. Hub don't understand MAC address and IP address. Switch understand MAC address and maintain a MAC address table. These are the basic few points plus differences. Next, L3 switches. What is a L3 switch? Actually, switch is L2. But what is L3 switches? There is L3 switch. It do function like a both switch and router. Means switching and routing. Both concepts works here. What is switching? Switching means like a MAC address table creation kind of stuff, connecting devices in the LAN network. Of course, there is important switching concept is VLAN creation, inter-VLAN communications, okay, switch port security. These are all switching functions, switching configurations. Router is used to send data from one network to another network, not sending exactly. It shows the path to reach the destinations. Means now we are able to communicate different websites, right? Google.com, Facebook.com. We are able to communicate because of in this world there is several routers are there. These routers will tell you how to reach the destination. So L3 switches do both the functionalities. Yesterday I stopped at here. right? So then we have to continue from router. Okay, router is a intelligent device. It works with a logical addressing like an IP address. Okay, it is inter networking device, means it communicates between different networks. It connects to our more networks and make a communication between different networks also. It is used in both LAN and WAN communication, and it is a layer 3 device. It is a layer 3 device. The router one side, it is look like this one, guys. The router symbol is like a round with some, but it is so there is a console cable, auxiliary cable. The main important is this serial port. What is the use of this serial port? Okay, so to connect one router to another router.
Sir, your voice is not audible.
Okay, now can you able to hear?
Yes, yes.
Okay, so this serial port are used to connect for a WAN connectivity, point-to-point connectivity, kind of stuff. These are for configuring a router. This is for a LAN connection purpose. See, this WAN connectivity, this is for LAN connectivity. That's why it is switch is used in a, sorry, router is used in a both LAN and WAN communication. Router is used to connect different networks. Okay. Used to connect different networks and make a communication between different networks. Here it is. This is one network. This is another network. Router is there used to connect between these networks. Okay. This diagram I kept here. Okay. So in starting itself, I SOHO time, or no, not SOHO. First, internetworking, network and internetworking. How written this diagram? See, this is one network. This is another network. You want to make a communication between different networks. We need a router. Okay. Not only physically, also logically, also same thing. Router is important to communicate between different networks. It is internetworking device. It connects to our more different networks, LAN and WAN communication layer 3 device it is. Okay, it's coming to the switch and hub, guys. Okay, so again, this is it understand logical addressing means IP address. Okay, it is internetworking device. It not communicate within the network. It will make a communication between different networks. Okay, it connect different networks and make a communication between them. Use both LAN and WAN. Okay, and it is a layer 3 device. Hub is a layer 1, switch is a layer 2, and router is layer 3 device. What is this router or router? It is actually root. router. Route means what? Path. What is router will do? Router shows best path to reach the destination. Router shows best path to reach the destination. Routers use routing table to know the how to reach the destination. These routing tables you are used to get to know how to reach destination. Both lines are same. Okay, both lines are same, but I have written 2 times. Okay, so what is the routing table? Okay, what is the routing table? Routing table will tell you how to reach the destination. Like a path, it will tell which way you have to go. Okay, what is the best path to reach the destination? Guys, in global age, so there is several routes are there, several ways you can reach the destination. But which way is best path? Just for our understanding, you are in a place like you are from your home, you came outside first, that is default gateway, you came outside of your through your gate door, you came outside of your home. Now you have to reach railway station or a bus stand. So how to do? Which way? You will take a left side or right side? What is the next stop? So like maybe sometimes multiple routes are there. So which route is better? Which route does not have more traffic? Which route is a more clear route, means wider route it is. Highway kind of route is there. Or maybe it is even a smaller. When I was in a Pune, so compared to like you want to, if you are going on a main road, it take lot of time because of traffic. The small tiny routes are there, that is faster you will reach it. Okay, so like that. So it depends upon traffic, bandwidth, link status. It will calculate what is the best path. Okay, so that is the actually another part. Okay. Of course, these routing tables can be created manually, like you can think and which route is the best manually can draw the, we manually can give routing. That is called a static routing. Another one is a dynamic routing. What is dynamic routing? You want to reach the destination. You want to reach, sorry, so somewhere I'm disconnected. Routing tables are created by automatically by using routing protocols, using certain routing protocols like RAP, EIGRP, OSPF. Okay, using certain routing protocols. Again, I'm telling guys, there is a different routing protocols. Using these routing protocols, the routing table will be created. That is called a, yeah, very correct. That is exactly how it is. Okay. So what is this routing table? How routing table is created? Okay, using dynamic routing protocols. These protocols automatically design the routing table. So then using that routing table, we can able to reach the destination. Like
So
this guys. Yeah, tell me.
what is static? I think there's something static protocol.
Which protocol?
No, can you show the screen? Like
One second.
it's static routes routing, manually called static routing.
Yeah, static routing. Yeah,
What is this?
I will tell.
Okay.
Okay, guys, this is three routers. Just for example, I'm for a basic understanding. Okay, it's not that much simple. It is very large network routers are there, but here this is the first router, router 1, router 2, router 3. Okay, just for first one. Here one network is there, network 1, network 2, network 3. In router, so because it is smaller, so no problem, manually I will write. In the router, I manually I will write how to reach this network and how to reach this network. In router 1. In router 2, I will write how to reach this network and how to reach this network. In a router 3, I will write how to reach this network and how to reach this network. Means I know my own network, but I should know the other networks, right? So in statically I am writing. So what will happen here? Okay, here is one PC want to reach this. Packet is going to router and is in a router it is telling I want to reach this one. It's outside of the network. So compulsory you have to go through this default gateway. So reach the router and telling I want to reach this particular device which is in this network. So what will happen? Router verifies where is this network? Where is this network? This network is towards this. So it will tell go to this route. Go to this route. This router take this packet. Router take the packet and check where is the destination network. Here it is. It forward packet to here. Okay. I will tell in a different way. So guys, this is my destination. Not different way, same story, but one more step. Same story, one more step. This is my destination. This is my source. How to send packet, right? First here to here, router. Router checks where is it, what is the destination? This is the destination IP. Where it is located. Not located here, but it will be available towards this. Towards this. Okay. The network is towards this. So what it will do? It send packet to R2 first because it is a next device, not R3, right? So this is the next device. It's sent to R2. R2 will check what is the destination. Here is the destination. Then it will which way, this way, and forward to this packet. And R3 check the packet. What is the destination? It is located in this network. It will forward.
Sir,
Yeah.
so while traveling the path from router 1 to router 3,
Mhm.
it will act as a default gateway.
No, no. Yeah, it is if it is a end device, it is like a default gateway.
Ah,
If it is end device,
acha, acha, acha.
like this. So think like this R2. R2 is not a end device, na? Both are there. Both side communication is there. The same goes with this one also. Same. Here one device is there. Want to communicate then R3, R3 to R2, R2 to R1, and it is the destination.
Excuse me, sir.
Yeah, tell me, tell me.
Is there any collision or data loss in this process?
Yeah. Data loss is data loss or not, it is not mean because it is sometimes. So how collisions will occur in the same road? Okay, if it is a very less bandwidth, same road or more traffic generated, there is a possibility of collisions. So then packet loss is there. But mostly, so bandwidth nowadays increases, right? So bigger the bandwidth we are using.
There's a less chance of this.
No, no, this is not. Point is not that one. Point is not from hubs and search. We should not compare their data loss or collisions with a router. Router is mainly outside network communication. This is one network, one logical network, one physical network. This is different network. You want to communicate
Okay,
from
sir.
here to here, so we need a router.
Okay.
Good. So, madam giving one link to you. Okay. Tell you to fill this one. Okay, guys, fill this part. Okay, at break time. Where I am, look at, yeah. Okay, so manually if I create, it's a static routine. If you want, I want to create, if it is a very big network, so I cannot create every routing part, every network knowing is difficult. So what I will do, I'll go with a dynamic routing. Okay. So this is the important points in the router, guys. First one is it is a intelligent device. Of course, that's not having any weightage, but it is works with a logical addressing. Switch work with a physical address, that is MAC address. Router works with a logical address, that is IP address. Switch is used in LAN communication and within the network type only. Router is make a communication between different networks, LAN and WAN communication. Okay. So switch is a layer 2 device, router is layer 3 device. Okay, in a router, in a coming to the only router part, the router use routing tables to reach the use the routing tables to tell how to reach the destination. Okay, this is not out of topic, guys, just for our understanding plus and one more comment. Then I will tell about a modem. Networking, there is a few important commands out of that one, so I'm telling two now. Ping and a Tracert. Ping, what is a ping? If you check in a Google, there is a abbreviation, packet internet grouper. Packet internet grouper. But you will try that abbreviation, but I'm telling what is a ping command? What is ping command? Ping command is a test command to test activity between devices, between devices from source to destination to test connectivity between devices. We use a ping command. For example, I have a device here. There is a device. Sorry. Here is a device is there. I want to test. Can I able to reach to this device or not? Can I able to reach this device or not? Okay. Can I able to reach this device or not? Exactly say this is a good one. Can I able to reach this destination or not? That is ping will tell you. Okay. If ping is successful, means your source to destination, destination to source communication is clear. Or A to B, B to A, two-way communication is clear. No issues in it. Okay, two-way communication. So it will tell it is confirms that both side IP addresses wise Okay, and connectivity wise it is. Yes. To test connectivity between devices. Of course, there's some details are there, so I'm adding that details, guys. Don't get confused. Ping command uses protocol that is ICMP protocol. Okay, that is ICMP. Okay, the request and response is echo request. Send echo request to destination. Okay. Destination send response. So echo request means what are you send, you will get same packet only. You send one packet, same packet you will send. The ping related packet you are sending. It's called a echo mechanism. Spelling whatever it is. Echo mechanism. So first of all we do ping, guys. We are going to command prompt. In command I am going to ping very simple way. I use www.google.com. I want to test can I able to reach google.com or not. Okay, the first it is returns an IP address. First I got a IP address of www.google.com. It's not google.com IP address, it is www.google.com IP address. Okay. Reply from where I'm getting reply. I'm getting packet reply from this IP address. Reply from destination. Reply from destinations. When you do ping to the remote device or a remote PC, remote server, you are getting a reply from means your ping is successful. You are getting a reply from destination means your ping is successful. Ping to www.google.com. I got a www.google.com IP address from DHCP server. So I send a packet. So I got a reply from destination. So then I am able to communicate it to www.google.com. This is what I am saying. It is ping command. Next one is Tracert. What is a Tracert? Tracert will tells how you reach destination. Not how to reach destination, how you reach destination. Okay, how you reach destination, Tracert will tell you. So we'll try same location, Tracert www.google.com. So why I am telling this one, guys, to understand what router is doing in the world. There is several routers are there. So there is several connectivities. One router is connected to another router, another router is connected to another router. Not in a single line. There is a net line. You know, have you seen fishnet? One is connected to multiple things. Okay, like that it is connected. One router is connected to multiple routers. It is covered entire globally. Okay, enter globally means you have multiple paths to reach the destination, but which is the best path will tell by the routers itself. Okay, this Tracert is telling how you reach the destination. How can you reach destination? How can you reach destination? The first one is I got an IP address of www.google.com. Next, from my laptop to my default gateway, from my laptop to my router, my default gateway, from that one to my ISP, ISP to outside of ISP routers, and then another router, another router. What is the meaning of internet? Networks of network. Internet is nothing but a networks of network. There is a multiple networks in the outside. So finally, I reached the destination. Finally, I reached the destination. This is also better to put it in a little dark. What is a Tracert? Tells how to reach the destination. So I am trying to reach my destination. See, from my PC to my router to my another router to another router, and some there is a router, there is another router. So finally reach the destination.
So can you explain me what is the meaning of 1 millisecond and all these things? Can
One.
here shows the time shows 50 millisecond, 50 millisecond, 50 ms
This one. That is not test.
broadband
Yeah,
and address.
we are
Can you explain
crossing
all
one
this?
to another one, right? You are crossing from here to here. How much
Okay.
time it is taken to reach this particular point? Again, how much time it is taken to reach this particular point? How much time it is taking to reach this point? From here to here, from here to here, from here to here, or from here to here. Okay. Sometimes unknown, it will take little bit
It
extra time.
means if we use two browser at the same times, then he shows two different IP address and timing, na?
No. So don't go to that point. Okay. So you use same website from different browsers. Maybe you may not get or may get a time more. Okay, because it's work like this. Catchy data type means in generally your ISP means sorry your destination is too long or maybe too near. So what ISP is doing, so most frequently used websites like a google.com, youtube.com, facebook.com, this kind of stuff. So the most frequently used websites, what they use a caches. Okay. So only for get authentication kind of stuff, you are reaching google.com, but data is mostly it is combined in the middle only. Okay. So you
Okay,
may not get a more time if you are using same website from different browsers.
okay, like that. I open my laptop. Firstly, I open my Gmail. Then I go to the YouTube. Then open my Facebook. Then WhatsApp. Then it shows in this IP address.
Simple, it's a good question, but you have a PC and you open a different websites
Yeah, at the same time.
same time, no problem. So Tracert is a test command, guys. First of all, remember Tracert is to know to reach a particular destination. You want to test from your PC to your destination, how you reach the destination. So in middle there is a lot of routers. Okay, they have to cross so many places. And you reach it. Okay, this is for Tracert. For tracing, how you reach the destination. Okay. Your question is, if you open a website, what will happen? First of all, if you open a website, in case like a simple, you open a website, for example, gmail.com. You know the IP address of gmail.com, which is if in case it is already in your PC, means based on the cache memory kind of stuff or not. It's okay, it will verify any cache memory kind of stuff is there in your PC having your Gmail IP address. Otherwise, it will send to your local DNS, which is nothing but your router. The router will send the query to outside. Finally, it will search. I don't go to that much. You will reach, your DNS knows now what is the IP address of gmail.com and you will get it. In earlier days, we have old type of browsers like a Internet Explorer. If you open any website, in the bottom of the screen, it's showing an IP address. Now it is not showing IP address to us. Directly it is connecting. Earlier days it is showing. Old browsers. Okay. So, but you open a website, google.com, facebook.com, youtube.com, we still need an IP address which is given by your DNS. So you got an IP address, then only we can connect it to that particular remote server. Okay. But here it is showing because it's a command. First I got a IP address. This still old style it is working. If you maybe anyone is using now, may not be. Any YouTube video is available. You may see when you type a URL in the browser and once you put enter, so in the bottom of the browser screen, it will show an IP address to which IP address it is connecting. Okay, I got your question. Okay. Guys, ping and tracert. Ping and tracert are test commands. Ping is it to test connectivity between the devices. So to know, can you able to reach destination or not? Okay, this is how ping command works. So you do ping to your destination IP address or a name. So if it is a public name, so then you may get an IP address and you will get a reply from IP address means your ping is successful. Why it is? You send a packet, so then destination understand what is your request and it will give you a reply. So it means two-way communication is good. Tracert tells you how to reach the destination. Tracert will tell you how to reach the destination. So this is a Tracert, www.google.com kind of stuff. So I want to know how I reach my destination. This is a google.com IP address. First, we should know the IP address. It means it is showing our IP address. First, communicate with IP address only, right? From my PC to my router to my ISP to another ISP. And in their routers and outside there are several routers. Okay, so it reach one by one and finally reach the destination. And we should reach maximum of 30 hops. Means these are the hop count 1 to 8 hop count. How many jumps you have done? So like that, okay. 8 jumps, by 8 jumps, I reach the destination. Okay, within the 30 jumps, you have to reach the destination. 30 routers you have to cross maximum. Why it is? Because of they're given a limit for that one. So why 30 means? So if it is n number of hops are there, 40, 50, 100 hops it is crossing, what will happen? The packet is traveling entire network. It is not reaching a destination easily. It's still rotating in your network. So a lot of packets will be in your network without reaching destination. They travel from here to there, there to here. Like that much not required. So there guys, these are the two main important test commands. One is ping, another one is a traceability. Last one in this particular topic is about modems. Okay, already I given the total diagram. So modem, modulator and demodulator, modulator and demodulator. That is a modem, modulator and demodulator. Modem used to connect ISP. Modem is used to connect ISP through the telephone cables or a to telephone wires. Old style it is telephone wires, telephone cables. Nowadays we are using fiber optical cables. Okay. Why it is called a modulator and demodulator, guys? In our network. So I am connecting with my laptop, right? It is in a different form of signal. It is a digital form of signal. That's normally people are calling that one digital form of signals. It is not a high strength signal. It is to transmit the data to the longer distances. What the modem will do, modem converts whatever the type of signal it is a radio signal, like I'm using Wi-Fi or wide network. So whatever the form of data it is, whatever the form of signal it is, it converts into the analog form, means telephone type of connectivity, telephone wire type of communication, or maybe fiber optical cable related that type of signal, it will convert. So what are the LAN communication you are doing, either it is wired or wirelessly, whatever it is the connectivity it is, it converts into fiber optical way, means like a light wave signal, or maybe it can be a telephone cable related that kind of analog signal it is converting. That's it is modem. It converts your signal to different form of signal like analog signals. Modem connected to internet. Without modem, we can't access internet. To connect internet, we need a modem. So modem make you connected to ISP. Through ISP, we will get an IP address. How you connected to ISP? So usually telephone cables are a fiber optical cables. Your modem converts your LAN in a LAN. What are the data digital form of signals? Either it is a Wi-Fi or wide kind of signals. It converts into fiber optical wave related by light wave signals or electrical signal which is used in a telephone cables. Okay. Some Wi-Fi routers having a built-in modems also there. Already I know default gateway part also. There is a modems, internal modem, external modem, or separate Wi-Fi modem, so many other modems also there. This is I already explained, guys, small office, home office kind of stuff. How you connected to ISP, internet service provider, through modem, router, switches, wireless access point. Topology kind of stuff we are completed. So then first I will go back. So I will tell about after break, guys, NIC and cables. So we'll start with NIC and about MAC address, okay, and about IP address, how to check IP address, MAC address. Of course, cables are important. So first is cables. NIC and cables. So we'll follow whatever it is, no problem. NIC and cables I will tell. So that's after break.
Hello, sir. Can you share the link?